you have to tell me what is it. So we daily come across it. The taste, the thing which you take inside, like lemon, vinegar, tamarind, how they taste? Sour, exactly. And when we consider coffee, cocoa, how they taste? Bitter. The sour one, what you call them? They are nothing but acids. And the bitter one? Exactly. They are bases. So today we are going to deal with acids and bases and their reactions. So first of all, before going to their reaction, we will get to know how we can detect the acids and bases. We can't taste all the acids and bases. If we see, the floor cleaners are there, the soaps and the detergents are there, and there are so many chemicals we use in our laboratories, and those are all not possible to taste. So there are some indicators which indicates what is acid and what is base. What are the indicators? The first one, as we already knew, that is the taste, by knowing the taste. The second, I can say it is phenolphthalein indicator. The third, I can say litmus indicator. It is very important and easy one. Methyl orange. And olfactory indicators. And there are so on. So the first one, I said taste, by which if it is sour, then it is acid. Yes, and if it is bitter, then it is base. And next, we were talking about the phenolphthalein indicator. It will change from pink to colorless or colorless to pink, and which will indicate us the base or acid. And the same way, litmus paper. If the litmus paper turns from red to blue, a very easy understanding is that blue. If it is from red to blue, then the given solution is no doubt a base. If a litmus paper turns from blue to red, the base is already fine, so the remaining one is. So the same way, pH indicators. pH indicators will be like, you'll study about it later. There will be a pH scale 1 to 14 that will decide whether the given solution is acidic or basic. And then the same way, as I said, olfactory. Olfactory is all about the smell. Depending upon the smell also we can say which is acid and which is base. That we will learn laterly and is not that important. We will discuss it if you need. Inshallah, comment me about it. Then coming to methyl orange. solution into red if it is base, and turn the solution into yellow if it is acid. Now coming to the reactions, first we will discuss how acids react with metals. So see this diagram carefully.
So this is a picture diagram of an experiment. Here you can see reaction of zinc granules with dilute sulfuric acid. As I said, here we have taken a test tube. In this test tube you can see the small particles, those are zinc granules, and then the solution which is in the test tube, that is dilute sulfuric acid. So when zinc granules reacts with dilute sulfuric acid, that will liberate hydrogen gas. That gas is passed through this closed pipe, and it is collected in this vessel having soap solution. So see here, a man is holding a candle. This hydrogen gas, when reacted with flame, you can see the flame, that will pops like a gas. You can see the sparks when you light a birthday candle. The same way, burning of hydrogen gas with a pop sound when it is burnt to a candle which is on, the flame is on. So this experiment condition is completely taken under very careful and precautionary measures. How the reaction takes place, now we will see.
How the dilute sulfuric acid reacts with zinc. That we will write it as, the reaction will take place as zinc sulfate is formed with the liberation of H2 gas that we seen in the diagram. In general, we can write this reaction as acid plus metal will give a salt and liberation of hydrogen gas. Okay. Next, how acids react with metal carbonates and metal bicarbonates. With metal carbonates and metal or we also say it as hydrogen carbonates. So now see this diagram.
Here is our another diagram. See it carefully. It is passing carbon dioxide gas through calcium hydroxide solution that I will discuss in the next equations. What happens here, you can see here also we have two test tubes. This one is one test tube and this is another test tube. So in one test tube which is connected to this stand, we are having dilute hydrochloric acid in it, and that contains sodium carbonate or it could be sodium bicarbonate. Sodium bicarbonate. Okay, sodium bicarbonate. When these two treated together, the hydrochloric acid and sodium carbonate, the gas which is liberated is nothing but our carbon dioxide gas, that is again treated with calcium hydroxide solution. This is lime water. It will turn the solution to milky white precipitate. This complete reaction is, we can assume, an example for gastritis. You just imagine having a gastric in your stomach, that is nothing but having HCl increase in your stomach. When it is increased, you will feel burning sensation, the acidity, we call it as acidity. So what we will do, we will treat it with sodium carbonate, or we can say that Eno, soda and all, right? When we treat this with these things, the gas held in our stomach and the acidity, the acid held in our stomach, it will be removed and we will feel free. So this is an example for that too. Here we can understand why the acids and bases and salts are that important. Next we will see the reactions regarding this.
Here also an acid is treated with metal. If we take example HCl, first we will take example of metal carbonate, that is sodium is a metal. Metal carbonate, this is sodium carbonate plus HCl is an acid. What we will get? We will get a salt plus liberation of carbon dioxide plus water. See whether the reaction is balanced or not. So the CO2 gas is liberated. In the same way as we seen in the experimental diagram, the metal bicarbonate, that is HCO2, when it reacts with acid, this is our metal, sodium we have taken. In general, we can write the reaction as metal carbonate plus acid. What we will get? A salt plus CO2 plus H2O. In the same way, metal bicarbonate plus acid, it will give the salt, carbon dioxide and water. And I did not explain the complete reaction so that you should not get confused. The carbon dioxide released during this reaction, when it is taken and treated with lime water, if the gas is passed to a test tube containing lime water, the lime water will turn into milky white precipitate. You see, the lime water is transparent, but when it is treated with carbon dioxide, it will convert into white precipitate. That shows that these metal, when metal carbonates reacts with acid, that will liberate carbon dioxide. How the reaction happens? It will liberated carbon dioxide with lime water. Lime water is CaOH twice plus CO2. What we will get? CaCO2
So in our next video we are going to discuss about definition of acids and bases, general properties and uses, importance of pH in our everyday life, and preparation and uses of these things, which are there: sodium hydroxide, bleaching powder, baking soda, washing soda, and plaster of Paris. So by completing all these things, in our next video we are going to complete the syllabus of acid, bases and salts of CBSE grade